Dave Staublin here, and we're talking today about arithmetic sequences. An arithmetic sequence is a sequence where you add a positive or negative number to get the next term in the sequence. Okay, so the next thing that we need to define is what's called the common difference, and that's represented by the letter D. The common difference is the number that you add, and it's either positive or negative, to get the next number in the sequence. Okay, so an arithmetic sequence is when you add a positive or negative number, and the common difference D is the actual number that you add. So for example, in this sequence, it looks like we are adding 3 each time. So this is an arithmetic sequence because we're adding a number each time, and the common difference is positive 3. So we would say D equals positive 3. And then we can figure out the rest of the terms. 11 plus 3 is 14, plus 3 is 17, plus 3 is 20. So let's talk about the recursive formula for an arithmetic sequence. What we're going to do is we're going to derive the recursive formula for this sequence, and then we're going to generalize it for any arithmetic sequence. And it works like this. We need to know the first term, so A1 equals 2. Now, to get the next term, we would do the previous term, 2, plus the common difference, which is 3, to get the next term. And then to get A3, we would take the previous term and add the common difference, and we would get 8. Then we would take this previous term, add the common difference, and we would get the next one. So this is A1, A2, A3, A4. Okay, so what we notice is that there's two things we need for a recursive formula. We need to know the first term, which in this case, A1 equals 2. And then you'll notice that A2 is equal to the previous term plus the common difference. So in our case, we would say for any term n, you would need to know the previous term, which would be n minus 1, and then you would add the common difference, which is D. Okay, so this would be the recursive formula for this sequence. Now, as it turns out, we can generalize for any arithmetic sequence the recursive formula will be A1 equals whatever the starting value is of the sequence. So I'm going to put a little box around this because this is the number that you'll plug in. And then any other term will be the previous term plus the common difference. And I'm going to put a little box around that because that's the other thing that you'll plug into the equation. So this is the general formula for any arithmetic sequence, the recursive formula. All you need to know is the starting value and the common difference. Plug it in here and you have the formula. Now let's talk about the explicit formula. Now, in this case, we know that A1 equals the value 2. And then A2 is going to equal, actually I'm going to move this over. It's going to equal 2. The next term is going to equal 2 plus 3. And then the next term is going to equal the starting value plus 3 plus 3. And the fourth term will be the starting value plus 3 plus 3 plus 3. And I think that's enough information for us to derive the explicit formula. So what we notice is that they all start with the letter 2, or with the number 2. And then it seems like this has 1 3, and how does that relate to that? This one has 2 3s, and it relates to that. This one has 3 3s, and it relates to that. Let's see if we can put this together. For any term, it's going to equal, in our case, the number 2, and then we're going to add to it the number 3, and it seems like we're going to add a different number of 3's each time. And so if the n value is 2, we're going to add 1 3. If the n value is 3, we're going to add 2 3's. 4 is 3 3's. So it's always 1 less than the n value. So this is the explicit formula for this sequence. Now let's write the explicit formula for any arithmetic sequence. We'll see if we can generalize it. Well, let's see. We have an equals, this number was our starting value, so I'm going to write this like this, starting value, and I'm going to put a box around it because that's something we'll plug in, plus, in our case, the number 3 was the common difference, and I'm going to put a little box around that because we'll plug that number in, and then it's times n minus 1. So that is the general equation for any arithmetic sequence. This one is explicit, and this one is recursive. Let's do one quick example. Let's say that our common sequence, or not, our arithmetic sequence is 90, then 95, nope, sorry, 90, then 85, then 80, then 75, then 70, and so forth. So there's two things that we need to know. We need to know the starting value, which in our case appears to be 90, and we need to know the common difference, which is -5. Okay, so if we wanted to write the recursive formula, we would do A1 equals our starting value, which is 90, and then any value or any term thereafter is the previous term, oops, that should have been a 1, is the previous term plus the common difference, which is a -5. And then our explicit formula will be an equals our starting value, which is 90, plus our common difference, which is -5 times n minus 1. And there we go. For this arithmetic sequence, we've written both recursive and explicit formulas.